Okay, now we'll make it so the player starts detecting when it is touching a wall or not. And we're going to be doing this exactly the same way we did the ground check. So let's start off by creating a new empty child, and we'll just call this wall check. But now instead of using a physics 2D overlap circle, we're going to be using a raycast. So let's bring up our script, and we can see, okay, so we need a boolean first to store if we're touching the wall or not. So let's say private bool is touching wall. And we can set this in check surroundings. So is touching wall equals physics 2D dot raycast. And we're going to use the fourth version of it. So we have an origin, which is going to be wall check dot position. We're going to have a direction, which is just going to be, we're going to project the ray towards the right out of the character. So to do that, we can say transform, which is going to refer to the transform of the character of the player itself, dot right. And now we need a distance, and we're just going to say wall check distance, and then layer mask, we're going to again use the what is ground. So we need to go up and declare this wall check distance, which is going to be a float. So it's going to be public float wall check distance. And now we can draw another gizmo in the scene view so we can see where we're checking for the wall. So we can just come down here and say gizmos dot draw line this time, seeing as it's a raycast, and the position is going to be wall check dot position. But now where we're drawing it to needs to be a new vector 3. This is going to be wall check dot position dot x plus wall check distance, wall check dot position dot y, and then wall check dot position dot z. And so if we save this and go back to our game, go back to the scene view, click on our player, and I should put in a wall check distance. Just make it 1 for testing, and drag in the wall check child. You can see over here is the line where we check for the wall. So it doesn't have to come out that far, maybe about a pixel. So let's just make it 0.25, nope, 0.3, nope, 0.4, okay. Yeah, so we can make the wall check distance 0.4. And then now if we run into a wall, if we put the inspector back into debug so we can see the private variables, we're not touching a wall. If we go all the way over here, you can see it registers that we're now touching a wall. Okay, next we need to get the character sliding down the wall when we are touching a wall. So to do this, let's go back to our script, and we now want to write a function that's going to check whether or not the character is currently wall sliding. We're going to call it from update. So we're going to say check if wall sliding. And let's just write it down here. So private void check if wall sliding. And we can start out by declaring another boolean. It's going to keep track if we're actually wall sliding or not. Because if the character is touching the wall but it's on the ground, we do not want to be wall sliding. So private bool is wall sliding, like that. So in check if wall sliding, we're going to say if is touching a wall and the character is not grounded. and the velocity of the character in the y direction is less than 0. Because if the character is jumping up against the wall, we don't want that to count as wall sliding, only when the character is moving down against a wall. We're going to set is wall sliding equal to true, else is wall sliding is going to equal false. So now that we know the character should be wall sliding or not, we need to limit the velocity of the character downwards when he is wall sliding. So let's go back to apply movement. In apply movement, we're going to say if is wall sliding. We want to set the downward velocity to a specific value. So we're going to, inside this if, say if again, and we're going to look at the rigid body dot velocity dot y and see if it is less than the wall sliding speed that we're going to specify. But just for convenience sake, we're going to say negative here. That way we can just specify a positive value. So let's go up here and declare that value. So public float wall slide speed. We come back to apply movement. So if the velocity at y is less than the wall slide speed, we're going to set the velocity equal to a new vector 2, rigid body dot velocity dot x, and negative wall slide speed. Let's head back to the game and let's try this out. Oops. Head back to the game. Click on our player. Let's set the wall slide speed to something like 2. If we now run the game and we walk up to a wall, as you can see, we are now sliding quite slowly down the wall. We can adjust the value over here. So if we were to set it to 0.1, you'll see we'll slide down very slowly. Perfect. Okay, so now let's go ahead and set up the wall sliding animation. You know the drill. Let's just open up the animation window again, go find our sprites, click on player, say create new clip, find the animations folder. We're going to call this animation wall slide. And again, this animation only has one sprite currently, so we can just drag in that sprite and it should be done. Now if we go to our animator, we'll see we have the new wall slide state. We again want to be able to go into the wall slide state from any state. So we'll make a transition from any state to wall slide. We need a new parameter. That's going to be another Boolean, and it's going to be called is wall sliding. And this transition is going to be made. It doesn't have an exit time. It doesn't have, it doesn't have an exit time. We pull this, we make this small. And under conditions, we're going to say is wall sliding equals true. Now we also need to go back to the jump/fall blend tree and add another condition to this one. So that's going to say is wall sliding is equal to false. This way, when the character moves down against the wall, it doesn't want to go into here, but it'll rather go in here. And then again, we can make a transition from wall slide to idle. I'll just move down here for now. If is wall sliding equals false. Now if we jump back in our code and we just update the animation and we say anim.set bool is wall sliding with is wall sliding, our animation should work. Head back to our game. Play this. If we walk up to a wall, just get this nice and big. As you can see, the character is now sliding down the wall. We have an issue though, where depending on how you want the controller to work, for my wall jumping to work, I do not want the character falling off the wall when I attempt to move away from it, because that is how I am going to determine whether I just want to jump off the wall or whether I want to jump like higher up the wall. So now to do this, we want to not change the velocity of the character in the X direction when it is wall sliding. So let's head back to our code. And the best way to do this is when we go to apply movement. The first one, we're going to say if is grounded, and throw that in there, so that we'll only move when the character is, or we'll only change the velocity if the character is currently grounded. So you'll see what effect this has if we go back to the game and play it. Notice how if I jump and try and move, the character doesn't move until it touches the ground again. But if I'm moving and I jump, the character already moves. Now this is not exactly the behavior we want. We'll fix that in a sec, but this is just to make it so that when we're sliding on the wall, we don't move away from the wall. But we still have an issue where when we're sliding down and we attempt to move away from the wall, our character still falls down. That's because the character is still busy flipping. So let's fix that in the code real quick by going down to the flip function and saying if not is wall sliding. Then we can do this stuff. And you'll see when I slide on the wall now, the character will not do anything when I push any of the buttons. Perfect. So now before we head into the last and most important part of the wall jumping, let's quickly fix a few things like what we just showed with the character not being able to move in the air. Because how the wall jumping is going to work is we're going to, instead of setting the velocity directly, we're going to be applying forces. So while the character is not grounded, we want to move using forces. And I think that makes sense because we don't want the character to be able to move in the air the same way it moves in the ground. But we still want to have some degree of control over how the character, or like where the character is going, but we don't want it to be as snappy as it is on the ground. Well, for this character controller anyway. If you want it to be more snappy, you can always change it. But so for this one, what we're going to do is go to the code. And we're going to start out by defining a new variable that's going to be a public float. And we're going to call this movement force in air. So this is going to hold the force that is applied to the character as it's attempting to move in the air. So if we go back down to apply movement, we need to now apply this movement depending on the conditions. So if the character is not grounded, we'll say else if not is grounded and is not wall sliding, and movement input direction does not equal 0, we're going to apply this force. So we'll declare a new vector2. We're going to call it force to add. And we're going to set it equal to a new vector2. And in the x direction, it's going to be air movement force, or the movement force in air. and we're going to multiply this by movement input direction so that we can apply forces in both directions. And then in the y direction, it's just going to be 0 because we're only moving in the x direction. And now all we need to do is add this force by saying rb.add force and then this force to add. Now, with the forces though, we're going to keep increasing the velocity by adding more forces. So now we also want to clamp the velocity in the x direction again. So in here, we're going to say if the absolute value of the velocity in the x direction, so mathf.abs rigid body dot velocity dot x is greater than our movement speed variable that we declared in the very beginning, we're going to set the velocity directly again. So rb.velocity equals new vector2 movement speed times movement input direction and rb.velocity.y. So we go back to the game now and click on player and just set this movement force in air. I'm just going to set it to 10 for now. You'll see that when we jump and we attempt to move, the character can still move a little bit, but if we set this force up even higher, I have mine set to 50, the character still moves quite well. Well, we do currently have some sort of wall jumping, but this is not quite what we want. Doesn't always work. As you can see now, when we jump and we move sideways, if we let go of the keys, the character doesn't seem to slow down. It just keeps moving at that velocity, which isn't very nice to control. So now let's slowly bring down the velocity once the character isn't giving any more input. So let's go back to the code and we'll create another else if. So else if not is grounded and not is wall sliding, and this time movement input direction equals 0, we're going to say rigid body dot velocity equals a new vector2, and this time we're going to say rigid body dot velocity dot x multiplied with some sort of air drag multiplier that we're going to declare in a second, and we're going to keep the y velocity the same. So let's go up and declare this multiplier. And I'm just going to set this equal to 0.95 f to begin with. If we go back to the game now and play this, we'll see that when I jump and don't give any kind of input, the character slows down, but not instantly. If you wanted the character to slow down instantly, you could just set the air drag multiplier equal to 0 and the character will come to a stop immediately. We're just adding a bunch of different variables that we can tune to change how the character moves. The next thing I want to add is a variable jump height. I don't like that when I tap space and when I hold space, the character jumps the same height. So to do this, let's go back to our code. We're going to declare another float, and this is going to be called variable jump height multiplier. And I'm just going to set this equal to 0.5 f by default. Okay, now what we want to do is we want to detect when the player lets go of the jump button. So we can go to check input and we're going to say if input.get button up, and this time it's the jump button again, we're just going to cut that upwards velocity. So we're going to say rb.velocity equals new vector 2. Keep the x velocity the same. And then we're going to set the y velocity to what it is multiplied by this variable jump height multiplier. So we go back to the game again, wait for it to update, and then play this. You'll see that when we hold the spacebar, we jump as high as we used to. If we tap it, we just do little jumps. And that's a super easy way to add variable jump height to your game. Okay, we're getting there. We're getting there, guys. Soon we'll be able to jump off the walls.